Okay, hi guys. I wanted to give you guys a quick tutorial on how to graph quadratic formula functions, namely parabolas, as quickly as possible without the use of a table and without the use of a graphing calculator. To do that, though, let's just look at the very basic primitive version of the quadratic function, which is just f of x equals x squared. And let's also approach it from a table perspective. So if we were to approach this and look at, say, when x is 0, you square 0, you end up with 0. And then when you square 1, you end up with 1. You square 2, end up with 4. You square 3, you end up with 9. Realize that the same is true when you go the other direction. Negative 1, square it. Negative 2, square it. Negative 3, square it. And so what you end up getting here are these 7 points arranged just like that U-shaped parabola that we know and love. The thing to pay attention to here with the particular function is that as we focus specifically on the vertex, as we go 1 to the right from the vertex, we travel up 1. As we go 2 to the right from the vertex, we travel up 4. As we go 3 to the right, we travel up 9. That's that square relationship that you're seeing here. 1 to the right, up 1. 2 to the right, up 4. 3 to the right, up 9. All from that vertex right there. And so that would be our parabola right here. So let's move on and look at some more advanced looking equations. So what happens if we now take an x squared function and just put a plus 2 on the end of it? Well, when we look at the table here, if we were to look at 0, instead of getting now just 0 here for our y, we have really 0 plus 2, so we end up at 2. Notice what's going to happen here as we start to work our way out is we're really just adding 2 each time to each one of those y's that we would have had in the first place with the other function. So 1 squared is 1, but 1 plus 2 would give us 3. 2 squared is 4, but 4 plus 2 would give us 6. And the same would be true on the other end of things. We'll still end up with a 3 and we'll still end up with a 6. So that symmetry is a big part of these functions here. So when we put these values here, notice that when we have that vertex in play right there, notice from here we go 1 to the right, we go up 1. It's the same is true here, and actually I have the vertex in the wrong spot. So let's move that up where it should be at 0, 2, and then we have a point right there. And then notice here, 1 to the left, up 1. This point over here, 1, 2 to the left, we go up 1, 2, 3, and 4, putting us at this spot right there. Notice I'm not traveling from the origin, I'm actually traveling from that vertex point. And so there's our parabola right there. Let's look at another one. Notice plus 5, you betcha. We don't even need to graph it right now. I think we know what's going to happen. Instead of having it at 0, 0, now we're going to be up here at 5. 1, 2, 3, 4, 5. And then the parabola is still going to go 2 for 1. It's like this with that symmetry. And we'll get those other 2 points floating somewhere up here, right? But do we know exactly where they'd be? Well, sure. 1, 2, 1, 2, 3, 4. So maybe this other one was maybe just a little bit too high. So there we go, and there's that U-shaped parabola right there. Notice that one thing that doesn't change when we're just adding that value to the end of it is it doesn't change the relationship of the other 4 points that we have here, 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 and here. It doesn't change that relation, that distance from that key vertex point right there. It's still 1 to the right and up 1, still 2 to the right from the vertex and up 4. Now it's minus 3. Realize that once you go with that point 0 right there, it's going to be 0 minus 3, so we're down here at negative 3, and there's our vertex. And just because it's down here doesn't mean the parabola is going to open downward. Notice what happens here when we plug in a 1. We're going to get 1 again, but 1 minus 3. When we square that 1 and get 1 and minus 3, we end up with negative 2. So that point ends up right about there, right? So notice the parabola is still opening upward and we still have that symmetry going on. Remember here, 1, 2, 1, 2, 3, 4. And then 1, 2, and then 1, 2, 3, 4. Still that U shape. Same concept here. So you notice now we're graphing it without even having to even think about the table. 2 for 1. Okay. So no matter what that value is right there, what direction will the parent function go if there's a value in the k place? Well, if k is positive, it's going to go up. And if k is negative, it's going to go down. But it's going to stay right, that vertex is going to stay right along that y-axis there, isn't it? What happens if we now shift it and we look at something like this? Well, what do you think is going to happen now? Instead of moving up and down, you bet it's going to move left and right. But be careful here. Notice what happens in this case. We put a 0 in here. Notice here we're going to take that 0 and we're going to have to add 3 to it first. Interesting. So 0 plus 3 gives us 3, and then 3 squared would give us 9. I wonder if that's where our vertex is at. I don't think it is. Notice what would you need to take to make that squared number to get smaller? I think we'd have to use a negative number. Use a negative number instead of a positive or a 0. So what happens? Notice what happens if we tried a negative 3. See why I might have picked negative 3? Because that would make that parenthesis quantity in there be 0, and then we have 0 squared, which would end up as 0 right there. So now we would have a point right here at negative 3, 0. Interesting. Notice that if we move on just to the right of negative 3 and go to negative 2, negative 2 plus 3 would give us 1, and then 1 squared would be 1. Notice if we move down to negative 1, inside the parentheses we end up with a positive 2, and positive 2 squared would be 4. Notice here, 1 to the right, up 1. 2 to the right from that 3, we went up 4. So that shape is still in play here. Notice what happened with this U-shaped graph. Realize if we went in the other direction, you know what's going to happen. If we go to negative 4, negative 4 plus 3 would give us negative 1, and negative 1 squared would put us right there at 1 again. So there we go. Notice we're seeing the left and right, but it might not have moved in the direction that we thought it was going to. If that's a plus 3, we might have thought it might have been going to the right, but in actuality, when there's a plus sign in there, it's actually moving to the left. Notice this one's going to move to the left from the origin, but now it's going to move 4 to the left. We still have the same shape. So hopefully this video is helping you a little bit at graphing these quickly. We can go a little bit further. I probably don't need to speed. I could probably speed through these ones here. But realize now that it's a minus 1. We're going to start here, but then we're going to move 1 to the right, and then we'll have the same shape. So we can fill in that U shape from there. So notice that when there's a value inside the parentheses like that, this is what's going to take that graph and move it now left and right. What is it going to take to move it to the left? Do you remember what happened there? What we're going to have to see when it moves to the left is actually we'd see a negative h moves it to the left. Because a negative h would actually just make that end result a positive like we were seeing there before, right? But if h was positive, in other words, if the minus sign was there, then we'd end up moving it to the right. So if we have a positive h, it's going to go to the right. Now you see what happens when we combine them both together. Realize it's actually telling you where the vertex is at. So that's why we call this here vertex form. And the trick is you look at that right there, remember the opposite move right there? So it's going to go 3 to the left. But it was the same move right there. Remember when it was plus there, it just moved up. So here we go at 1. So we know we're having a vertex here at negative 3 and positive 1. And guess what? Negative 3, positive 1, the shape is actually still the same. So from the vertex, 1 to the right, up 1. We get 2 for 1. 2 to the right, up 4. Notice I'm moving from the vertex and not the origin. And also notice I'm not moving from this point here. If I go 2 to the right, or to the left here, and then move 4 up there, realize I'm definitely not symmetric. The way this works is you got to start from the vertex, 2 to the left, 4 up. And there's your U-shaped graph. Same deal right here. Where's the vertex? Negative 4, negative 2, opposite game here with the 4. So we got to go 4 to the right, and then still keep the same right there, so 2 down. So there'll be your vertex, you can fill in the other points from there.